Hello, all of you people. I need to ramble a bit, so let's try to do something useful at least. Because I'm working on games, like multiple games, I'm constantly thinking about how to make the process more efficient, more elegant. Um, there are always there's always a lot to do in games. There's a lot of manual work that has to be done, um, and that probably should not be required. But it's often done because of the possible bugs or because of the lack of knowledge, lack of technology. Basically, games are complicated. Making games is costly. So we want to minimize that. Of course, simplifying the design is the one of its parts. But let's think about an overarching architecture a bit. Um, so I was asked recently about an interesting topic, which is basically a vast open space world for an RTS game. And one of the issues that people encounter when are trying to tackle such huge worlds is that the coordinate system based on 32-bit floats is not enough. Um, as you may know, the further you go from the zero to the float max, uh, max or float min, uh, mean, whatever, the less accurate each step will be. So first thing that people want to do is to move from engine that supports only 32-bit coordinates into 64 bits. Basically, this gives you an order of magnitude more precision, which means that you can effectively go much further from your original point. Let's say that this is your origin point, and with 32-bit you can get somewhere here, and with 64-bit you can get somewhere here until you encounter uh, inaccuracies that will basically destroy your logic. But the thing is, you'll still have this limit above above which you will not have enough precision to do the simulation. Uh, of course, for the player character and the player camera, the first thing to do is treat the player or camera position as the origin point and move everything else that is in the space. But if you need to tackle interactions between those 2 points, it still will be bad. Uh, another technique that is used, and more or less I think it's used also by Minecraft and things like that, is separating the word chunks into clusters. So we can basically decide on some cluster size and separate the word. Here it will be in a grid manner because I have a 2D space. But the idea works also for 3D space where you simply have cubes instead of grid. One of the assumptions that we probably can safely make is that whatever entities, whatever actors do we have, whatever they do, their interaction is limited in range. Which means that if we have point here, an actor here, entity, game object, whatever, we will probably have, can I draw it like here? It's not the best. Can I increase the size? Okay. So probably it has some limited range. For example, for weapons, for communication, for whatever. At least for the interactions that are space-based. Because communication doesn't have to rely on space, so we don't have this issue for like direct event sending. What I mean by that, if we have a mothership that is here, and the decisions and behavior of the mothership depends on whether or not the like attacker ships, whether or not they survive an attack. So let's say here we have its attacker ships, and let's say that if some of the attacker ships are destroyed, then the mothership has to trigger some task. For example, let's say build another attacker ship. And this type of interaction does not depend on the position of the entities in the world. So it's not a space-based relationship. It's not a space-based interaction. So we simply need to have a way to send a signal, an event from those ships, and a way for the mothership to listen to those events, which will probably be some dispatcher in the code that is not related to any of the position stuff. We need basically the space-based interactions only for movement. In case we don't want ships to bump on each other or onto asteroids or something else. So for movement and for attacks, like let's say a laser beam or some rockets or something like that. So in those cases, yes, we need a position-based interactions. So the function that evaluates this, let's get back to the assumption. So we safely can have an assumption that the effective range of the laser beam is limited in range. So we won't be able to shoot a laser from here to here. We probably won't be able to do that. And even if we can shoot up to here, then still probably there is a hard limit how far we want to shoot. But to be honest, even if the range is not limited, we still will be able to work around this with clusters. But bear with me. And in case of rockets that also are like time-based entities, oh, sorry. So rocket moves a bit in one frame, then a bit in next frame, and so on and so on. Like in each frame, the range of possible targets of the rocket is limited by its velocity. So we basically can do a custom interaction function that treats the attacker point as origin, or even if not as a origin, we can treat the cluster that attacker is as an origin cluster, and we can basically limit our calculations. So let's say that we have a range that moves from one cluster to another. So first of all, we declare a list and we list all enemies, all actors that are in clusters that touches our possible range. So in this case, those are the clusters that are uh, in this range, more or less. So this cluster actually is excluded even. So first of all, we get all clusters that are in possible ranges. And now we treat the origin of this cluster as our new 0.0, like origin of the space. And now we can translate the positions of all of those actors to be relative to this position. So we know the index of a cluster of this ship, and we know position within this cluster of this ship. So we can easily recalculate, like remap this to a position relative to this cluster. And that way, we are still in a range of 32 bit float precision. And we can, sorry, and we can very simply do calculations like two circles, if two circles hit each other, if a line crosses a circle, and so on and so on. We can basically code ourselves not only the position, but take into account size of the ship or even shape of the ship. Remember, the basic shapes will be easier for us to code because the algorithms are easier. Circle is probably the easiest in whatever you do. Sometimes axis aligned bounding boxes might be a tad easier, but those two are your basic things. Axis aligned boxes and circles are your two basic things that you should have in your toolbox. Then once you have this, you can have like arbitrarily rotated boxes, and only when you are sure that this is not enough for you, then you can try to complicate things more. But most likely you will simply compose your complex shapes. You will approximate those with multiple simpler ones. But that's a bit of a tangent. So we can do something like this. And once we have this, we can have like potentially infinite words, because each cluster is basically an entry in two-dimensional, or in case of 3D space, an entry in three-dimensional array. And indexes of this array is basically integer based. And even if you go beyond the range of integer numbers, you can basically add a layer on top of that. So you can create a cluster of clusters, then you can create a cluster of clusters of clusters, and so on and so on. And you can use long numbers instead of integers. You can even create your own type of integer numbers that is like 128 bits and so on. So you can very easily, once you have this basic stuff, you can very easily make the simulation word bigger and bigger and bigger in space. But let's go for a moment into the issue of insanely long ranges. So let's say from here to here. If this is a straight line, so we have not only the magnitude, the magnitude is in theory infinite, okay? We will need some range limitation, but it can be procedural, like it can be dynamic. So we have a line that has only direction. And this is great, because having a direction, we can basically iterate through all clusters that this direction moves through. So let's get a pencil again. Let's have this. So if we have origin point and direction, so we know that the first cluster that we need to check will be the cluster of the origin point. So we take this cluster and we basically evaluate our function only for this part. And we basically create a list that contains all of possible targets in the cluster, and we check if any of the targets crosses this line. And then if we have at least one target that crosses this line, we then check which is nearest to the origin point. If there is no such target, then we basically declare that our new origin point is here. We check through each cluster the beam, the laser goes starting from this origin point, from the boundary of a cluster. So now we can easily determine that this is the cluster that we are interested, and we repeat the same function, but for this part of a beam, taking into the account actors that are here. Of course, because actors are not just simple points, then we need to have a little bit more sophisticated way, which in the most naive approach will be simply to get actors that are not only in this particular cluster, but also in clusters like nearest neighbor clusters. Of course, that means that we will iterate through the same actors multiple times, but in most cases this is not a big issue. If we really need to optimize that, we can do a different type of cluster assignment, so an actor can be assigned to multiple clusters. That way, the cluster assignment itself will take into account the size of the ship. But as I said, very often the simpler solution will be enough, so we can iterate through the nearest neighbors also. And if there is no hit here at this point, we simply iterate more and more and more and more. And the like stop logic, the stop condition for this iterative algorithm, for this iterative approach, can be twofold. One is the range. If we can declare a range of this beam, then that will be one of the conditions. But another condition will be whether or not we have actually constructed clusters beyond some point. Especially in the dynamic worlds that we're talking right like here, we will probably add clusters dynamically because we don't want to declare memory and iterate through memory when there are no actors in such clusters. So at some point, we will see that we have no clusters beyond some point. In this case, it will be beyond this point. We don't have any clusters declared yet, so we know that there cannot be any hit. No clusters, no hit. No clusters, no actors, no hit. And even if we did a slightly different approach, then probably you can determine that beyond this point, even if there are clusters, those clusters are empty. There are no possible targets in clusters beyond that. So we can also use this as our stop condition for this iterative algorithm. So basically that's it. This is how you can create a potentially infinite world for, let's say, RTS game, or basically any game that requires a quasi-infinite space of a simulation. So this will be it for today. This rant is improvised, so sorry for rambling, but I hope it's somehow at least useful. Bye for now and cheers.